Hello everybody, welcome to section 4. This is going to be on plate boundaries. These are the places where the two plates meet. And if we take a look at our map here, there's actually a lot of different ways that this can happen. So a lot of different sorts of boundaries that we can have between the plates. For example, if we look here, we have South America here and the Nazca plate here, part of the Pacific Ocean. And we can see that it's actually colliding with South America. So what's happening here is we have the Nazca plate on one side and the South American plate on the other. The Nazca plate is actually subducting, is the term, beneath South America. And actually, as it does this, a part of the plate that's going down melts and sends molten rock up. And so we get all these volcanoes along the western rim of South America and our Andes Mountains. We also see places where we have a divergent boundary, so two plates pulling apart. Best example of this is to look here. This is the Mid-Atlantic Ridge. So you can see that the plates here are moving in the opposite direction from one another. And as they do this, hot material rises to fill the gaps. And as it rises, it melts, and we get new ocean crust formed at the surface. And finally, we have these little odd guys. These are transform boundaries, where two plates are sliding past one another. And as you may very well know, this part of the U.S., western part near California, is pretty active, so there are some pretty interesting things that can happen here. So convergent boundaries collide, divergent boundaries divide, transform boundaries slide past one another. Our convergent boundaries are going to be places where two plates are being pushed up against each other. And when this happens, we call it a subduction zone. One of the plates, the one that's old and cold and dense, or usually an ocean plate, is going to start sliding down underneath the more buoyant plate, the lighter plate moving up. And it's going to pull everything with it and sink down part of the downward part of our conveyor belt, which is driving the plate tectonic process. Commonly here, these are going to be marked by volcanoes and mountains, as well as earthquakes. As it goes down, it slides past through the tremendous amount of friction between the plates here. And these can happen in three ways. We can either have ocean and ocean, we can have ocean and continent, or we can have continent and continent butting up against each other. For the cases of an ocean continent, typically the ocean plate is going to subduct beneath the continent. So they meet, they collide, and the ocean starts going down. It's old and cold and dense, and it goes downward. And you can see actually right above where it goes down here, it forms volcanoes. Part of it melts as it goes down underneath the continental plate. Magma rises up, and so we get a volcanic arc here telling us that it is this sort of boundary. One example of this is going to be in the western United States. Well, I should say the Pacific Northwest. We have volcanoes running all up here, Mount St. Helens, and this is activity which is a result of what we call the Juan de Fuca plate, which is subducting beneath the North American continent. We have another case, ocean. So you can have a young, light, hot ocean plate, and then another one which is old and cold and dense. And whenever they meet, the one that is more dense will subduct beneath the other one. But this is all happening underwater. So what we would see at the surface is a volcanic island arc. This is one of our signifiers that this is happening here. One example of this would be the Aleutian Islands and Alaska in the US. So all of this that we see here, this is a result of this exact sort of volcanic arc. You see that it's not a straight line, it's actually a curved shape here. And all the land material that we see here is produced from the magma that occurs whenever the sinking plate begins to melt and sends that hot material upward. We have another view of it here if you want to see. So a different kind, we can have two continents converging in a collision zone. And these tend to be, in terms of the structures involved, maybe the most complicated places on the Earth. We're talking about places like the Alps in Switzerland. You have two continents coming together, and sometimes you have some partial subduction, and sometimes what happens along with that is they collide, they come together, and they sort of do this, and we have a mountain range right where the two come together. You can actually see a great example of this with the Himalayas. So what's happening here is that the subcontinent of India, which as you can see is relatively undeformed, just a huge rigid block, is crashing into Asia. And as it does so, you have all of these mountains along the boundary, uh, showing what happens when these two continents collide and whenever the two start to burn up against each other. Um, Finally, we have our divergent boundaries. So back to the middle of the Atlantic Ocean, here we have two oceanic plates which are pulling apart from one another. And as they pull apart at our mid-ocean rift, they create this low pressure zone beneath them. And something comes up from the Earth to fill this low pressure zone, and as it rises up, it decompresses and melts and bursts out, creating new ocean crust. Um, Volcanoes on land produce, some of them, a ton of lava. But this is, by and large, where most of the molten material on the Earth is. All of the action is at the divergent boundaries as far as new crust being created. Example of this one. So this is an artist's depiction of the mid-Atlantic ridge. You can see Iceland here right on the ridge, and this huge crack running through between the continents, where two ocean plates are pulling apart. You can also have a transform boundary. So cases where two plates, nobody is subducting underneath another one, and they're not really pulling apart and introducing new material. Instead, what is happening is that they are sliding past one another. And just because they're sliding past, though, doesn't necessarily mean that this is going to be gentle. We call this a transform fault or transform boundary. And earthquakes are common here. You might want to think of like the western United States, but we won't usually see any volcanic activity associated with these. Nobody is sinking, nothing is pulling apart to let hot material up to the surface. A great example of this one would be San Andreas Fault. Very famous, you might have heard of, and you can actually see here that part of the US, Los Angeles, and some of the surrounding area of California is actually not on the North American plate here. And they're sliding past each other. So North America sliding here, you can see to the southeast, and this part, the Pacific plate, sliding to the northwest. And if we were to let this go on for a while, tens of millions of years, about what would happen is that this part of California would actually break off from the rest of the United States. And, maybe it wouldn't be the worst thing, but if we let this go long enough, it would actually keep going up. And it's thought that it would actually rejoin us up here near Alaska. So there's no getting rid of them forever. And this diagram, obviously something that you will have to completely commit to memory for the exam. I'm kidding, of course, just have to say that. This is something which maybe gives you an all-in-one. So, if you're preparing for an exam or you just want to know, hey, do I understand this material or not? Taking a look at this and seeing if all the terms make sense, if you maybe know what direction things are moving, if you have some idea of what is happening everywhere in this diagram, that would be one way that you can sort of test yourself, test your own knowledge. There are a couple things here, videos, which you might want to look at if you'd rather hear them explain it than me. I take zero offense. We have a plate boundary wrap and a plate tectonics video, which is a parody of Whistle. Might be something to check out. Section 5, we're going to talk about plate tectonics in Arizona.